Hello, I'm Dr. M. Kamakshaya, open source software evangelist and also a full stack web developer. I have been filming video demonstrations on performing data analytics using R programming language. In my previous video, I have explained some of the important prerequisites that need to be performed before going for factor analysis. I also explained what is the factor analysis and what are the different ingredients and also the sequence of steps. Now, as a matter of recapitulation, let me tell you the different steps that we have done in my previous in our previous video, in our previous in my previous video demonstration. I explained how to perform the statistical diagnosis with the help of three calculations. That is, first one is the Cronbach alpha, which stands for a measure of internal consistency. We need to pick up the Cronbach alpha value from the output results of R and then interpret the internal consistency. R Cronbach alpha happens to be, Cronbach alpha in this analysis turns out as 0.58, which is close to 0.6. That is the minimum value expected for any data set to carry ahead for factor analysis. Now, there is a test called Bartlett test of Porosity. In this, usually the observation must be that the p-value should be close to 0, which means we can reject the null hypothesis that there are some certain correlations, valid correlations among data variables. Now there is, third one is the Kembo test of sample adequacy. This is actually the test of partial correlations. The benchmark is that the overall MSA, measure of sample adequacy, should be 0.5. Then only the data set is construed to be suitable for factor analysis. Now there are also variable-wise MSA, measure of sample adequacy sample adequacy measures. For SAT1 it is 0.42, which is insufficient. SAT2 it is 0.41, SAT3 0.8. That is a mind-blowing value. And there are few variables in perception 1, perception 2. We don't have good values for the first two questions or variables. And perception 3, it has 0.67. That is again a good value. And attitude 1 and 2 we don't have, but attitude 3 is the third question belongs to the factor attitude. We have good value. So each of the first two variables happen to have very poor values of MSA, and the third question, each of the third question in all these factors has really a good value. Anyway, that is left to you. That is how you have to interpret the results from this analysis. Now in this video I am going to show you how to perform the factor analysis. Whenever I talk about factor analysis, it is just EFA for this video. It is not CFA. Okay. Now let us go to our markdown script, and now let me write a section factor. So the first section is the introduction, the second section is factor analysis, and we have a couple of subsections in between. They're all just factor analysis. Now here you can just pick some dummy information only to decorate or record. Okay, you just okay, I'll just do one thing. I already have psych. I use help FA. That is what is the statement which we are going to use to perform the factor analysis. Now here this is the description. I can just copy this and paste this here. You see this description is a subsection. Now I have to now this is just imagine that the description. Now I'm just going to introduce the code chunk by pressing Ctrl Alt I, and now there is a function called FA. Okay, you just have to press this button. It is just like pressing a button. If you are using this function, it is just like pressing a button to get the output for the. You don't need to worry. Just in SPSS you have quite a few things to do, and you will be always under confusion to perform the factor analysis. But in R, it's just a matter of one single function. Many people don't accept this fact, but that is a fact. It's not a fact, it is the truth. Okay, truth is the truth. You don't need to accept the truth. If we accept the truth or not, truth remains as the truth. Okay. Now FA, we have here I have to do. I just call fit, and now FA, which means factor analysis. Now whenever you, let me use it here. FA, is it FA? Then psych, FA fit. Okay, you don't have FA in psych. Do you have FA in psych? Where is FA? There are so many FA. I mean, you can do uh, really a wonderful analysis in psych. Psych really helps us to do. I think it should be FA only. Hmm? Psych, FA. Should be FA. Factor analysis. And there are so many functions. Yeah, FA in psych. Yes, correct. We have FA, and the data set is going to be factor that, right? That is it. That's all. You just have to. I think we have to supply the correlation matrix or covariance matrix. Let's just nit and see. If there is error, then we can always go back and perform the analysis. If it performs the analysis, then we don't have any problem. We can just go ahead and no, there is no analysis. I think we have to use summary. Summary fit. Just like summary statistics. I explained this in the descriptive statistics. We can go ahead and perform. We should be able to get the summary for this object fit. Yeah, you got BIC and all everything. Now you got chi-square statistic. Where is the chi-square statistic? This should be the objective function. This chi-square statistic and a p-value. The probability value is that. And then you have BIC, and BIC maybe RMSA. This is the mean squared error for residuals. That is 0.2. Root mean square residuals 0.23. This is not the way we get. This is not the exact. Shall we write the fit? Enter. I think we should be able to get the output results for factor analysis if we just execute the fit. Yeah, exactly. Now we got it. So we have that information, factor analysis output in the fit object. Okay, you don't need to write the summary fit. Now you have, this is a factor 1. Okay, we have only one factor in our data. We don't have 3 factors. Okay, there's only one factor. You see there's a beautiful loadings. These are all called loadings. See, perception 1, perception 2, perception 3, there's only one single factor. All satisfaction has negative loadings. Oh my god, this is a very interesting analysis. Suppose if you have positive loadings from the perception attitude, these individuals have negative satisfaction. If their perception is positive, attitude is positive, and their satisfaction tends to be negative, I don't know. This is a ridiculous observation. So the perception should corresponds to satisfaction attitude. If you have positive attitude, positive perception, that should lead to positive satisfaction. But this something reverse in this analysis. This scenario belongs to a particular situation where the individual's perception increases and attitude increases, then they tend to have very bad satisfaction levels. That's good. This is a negative product. A product which is not advisable to the people, or a product which is not advisable to the. Maybe there are some dark products, like where your satisfaction levels tend to decrease by your perception. Maybe some terrific brands, maybe some demonic brands kind of thing. This is actually the uniqueness. No, this is specificity, and this is uniqueness. This is communality. The communality always must be equal to 1. The uniqueness of this variable is this, and they're all very good values. 0.6 is 0.80, 0.50, 24 is not good, 33 is not good. They're all bad. This is specificity of this. Like suppose if you ask the question, how specific this in this set of variables, now you have a measure. This is what is the magnitude of the specificity of You see the maximum specificity. You see perception 3. This question is highly specific. Trying to be specific. I think this one. Perception 1 is highly specific in this set of variables, followed by perception 3, and then you have zero point 0.5, satisfaction 3, and then like that. Now uniqueness, you have the maximum value for attitude 3. This is trying to be highly unique in our data, and there is 0.61. This is next to highly unique. But anyway, if you observe very closely, you have some certain evidence that satisfaction is a factor. You see, all of them are unique. 0.5, 0.4, 0.7, and they're all negative. We have sufficient evidence in our data that satisfaction is a unique factor. We have evidence in our data that perception is a factor. But actually, the perception and attitude together, that is again, there is sense. It is highly insightful. The perception and attitude, if the perception and attitude increases, then that affects the satisfaction. Satisfaction depends on the perception and attitude. That way, the perception and attitude together can be a factor. There's nothing wrong. Even we can, perception as it is as a factor, attitude as it is as a factor. You see 0.5, 0.6, 0.6, they are close. 0.8, 0.6, 0.8, they are close. So that way we have enough evidence in support of. You have some other measures. Anyway, for this video I'm not going to explain you all these measures. You have correlations. You see how best these variables explaining this factor, unique factor in the data. You have 0.98. Oh, that is robust correlation value. So this is ultimate analysis in which we have robust evidence in support of our assumption that we have three different, not three different factors, one unique. If you imagine that there is only one single factor, then this is the level of evidence. Okay. Now I will change my analysis. This time what I do, I will request for factors. I think number of factors is going to be 3. If I just put number 3 here, let's go for health FA. You see here we got number of factors. Somewhere we should be having you see number of factors to extract. Now if I put 3, then I will be requesting, you can write n factors, something, no, but don't take risk, just leave it like this. Let us request for an analysis for 3 factors. Then how but before, okay, let's do this, and after that I will show you how to make a plot in support of analysis, whether this analysis supports 3 factors or not. You see here, let us go for the correlation value. Where is the correlation value? Yeah, here. SS loadings and everything. We don't have the correlation value. Okay, that's fine. Okay, let me not waste my time. Let's go for same loadings. There is nothing big difference between loadings. So this time I think the loadings are very close to each other. You see MR1, you have I think MR1 it contributes, MR1 explains beautifully. MR2 explains, where do we have? MR2 explains any factor? No, I don't think. Yeah, it explains satisfaction, and it cannot explain anything else. I think it explains attitude also. The values are very close. MR3, it explains, it don't explain satisfaction because 0.09, it cannot be comparable. Okay. It is not comparable with 0.46, 0.32. No, you cannot. Perception, no. And attitude, no. This is 3. Second one, no, I don't think there is any distinct. That is why SS loadings, MR1, MR2, MR3, they're all. Don't worry all these. If you don't know how to interpret all, I can explain you how to interpret all these values, but I don't like to. We should have. I think we have BIC. We can compare this BIC with some other BIC. Where is the chi-square statistic? I think here we have the chi-square statistic, 27.2 with a probability value close to 0. So the statistic is significant. That should be, the statistic always must be significant, which means we have some significant and valid relationships in this output. Why there is no reliability is this? I don't know why there is no factor. You have a thing called correlation. Can I search for no? Okay, leave it. So this is what is the output for. We have evidence in support of three-factor solution, but the evidence is not sufficient. So that is what is the conclusion for this factor analysis. But for MR1, you have overwhelming evidence that all these factors are vividly identified through factor number 1. But factor number 2, you can, when this is useful to understand, explain satisfaction, but it is not explaining the perception, and to some extent it also explains attitude. Factor 3 explains satisfaction, not that much, and also explains perception, but it failed to explain. Of course it explains attitude. Two of the values are negative, only one value, but not that much. So factor 1, it is actually this data falls under one factor solution, not under three factor solution. Now it is up to you to define these factors. Factor 1, what is factor 1? This is a negative relationship between the perception and attitude versus satisfaction. And factor 2, there is a positive relationship between the satisfaction and attitude. And factor 3, there is a positive relationship between the satisfaction and perception. That's good. That's really beautiful outcomes from this factor analysis. Factor 1 is the best scenario. Factor 2, relationship between satisfaction and attitude. Factor 3, satisfaction and perception. So factor 1 helps us to understand the relationship between satisfaction and perception. Factor 3 helps us to understand the relationship between satisfaction and perception. Factor 2, I'm sorry, I think factor 1 helps us to understand the relationship between all three factors. Factor 2 helps us to understand the relationship between the satisfaction and attitude. Factor 3 helps us to understand the relationship between the satisfaction and perception. So that is precisely the interpretation for this factor analysis. One factor, a single factor solution is best, and three factor solution is not good. But if we force the analysis, we can even get the. So that is how you can perform the factor analysis in R. And here, this is the place you can write your interpretation for, factor analysis. But I am not writing that. You can just issue 3. Then if you knit for it, then you will get. So one final thing is you get interpretation here. You have to write the interpretation here because this is your analysis. I am just going to close my video. That's enough for this today. I am creating this video for my students who is struggling to perform the factor analysis. Now, one final thing is I will just take you back to the folder where we save the outputs. I think temporary, right? No, not the temporary. Scripts, yeah, factor analysis, yeah, sure. So let us see, open this in browser. One final task. So let us see, factor analysis, introduction. We imported the data sets. With this, we have this code, outputs, and this is the output for this code. And now we perform the Kronberg alpha. Here, pick up the Kronberg alpha here. This is the value, Kronberg value, alpha value, and Bartlett test. This is the p-value. Cambo test. This is MSA. This is actually Kaiser-Meyer-Olikin index. This is a measure of sample adequacy. MS stands for measure of sample adequacy. The value should be close to 0.5. Now we perform the factor analysis. Yeah, one final thing. Actually, I told you I will be showing you how to. There is a visual for this. There are many visuals you can do. As I said, it is unending discussion. There is a scree plot. I think that will show you scree plot psych. Psych. In psych we have scree plot. That we have to do well before performing. In factor analysis, there is a scree plot. Okay, that is right plot. Now this plot, I just open the chunk and scree. Then use factor cat. This is the final thing. I'm just going to. This will show you how many factors you need to extract from your data. One final knit. for the plot, we should be able to see, yeah, this is the script. You see, two-factor solution can be the best solution for this data. You can go for the three factors. You see, the for factor analysis, two factors. There's a dotted line for the factor analysis and a continuous line for the, broken line for the principal component analysis. So both for factor analysis and, the principal components, I think you have, you can go for three factor solution. If you perform the principal factor analysis by using the principal components, you can go for the three factor solution. But for factor analysis, you can just go for the two factor solution. So minimum, you can extract two factors from this data. That is what is it. So whatever I told you, you have to write it here. From the above plot, it is clear that this data, which data? Fact, okay, whatever it is, sample data. This data can support only two factors through EFA. But for principal component analysis, you can go for that. Now here this is interpretation purpose. So this is how you can just one final let's see the interpretation just below the graph. And now, yeah. So here you have from the above plot, it's clear that you can just now when we refresh this page, we should be able to get the graph here. So this is how you can make use of Markdown and Knitr together to create the output files and do abundant of analysis in R and RStudio. Thanks, my dear students and viewers, for watching this video. This is for this video. Please press like button, stay tuned for the new content, and also subscribe to my video channel. Thanks once again for watching this video.